Good morning to all. Welcome to video lecture. A course material on AI 3403 Strength of Materials for Agricultural Engineering. Presented by R. Rajiv Gandhi, Assistant Professor, Department of Agricultural Engineering, Rogani College of Engineering and Technology, Palkulam. Good morning to all. Then introduction. The vessels such as boilers, compressed air reservoirs, etc. are of cylindrical and spherical forms. These vessels are generally used for storing fluids under pressure. The walls of such vessels are thin as compared to their diameter. If the thickness of the wall of the cylindrical vessels is less than 1 by 15 to 1 by 20 of its internal diameter, the cylindrical vessel is known as thin cylinder. In case of thin cylinders, the stress distribution is assumed uniform over the thickness of the wall. Thin cylindrical vessels subjected to internal pressure. D is equal to internal diameter of the thin cylinder. T is equal to thickness of the wall of the cylinder. P is equal to internal pressure of the fluid. L is equal to length of the cylinder. The cross section of the cylinder diagram. One of the internal pressure P, the cylindrical vessel may fail by splitting up into any one of the two ways. The forces due to pressure of the fluid acting vertically upwards and downwards on the thin cylinder tends to burst the cylinder. The forces due to pressure of the fluid acting at the thin cylinder tend to burst the thin cylinder. The first diagram is pressure forces, indicate the pressure forces. Second one, cross section of the perpendicular to the axis of vessels. Then next one, example. A cylindrical pipe of diameter 1.5 meter and the thickness 1.5 centimeter is subjected to an internal fluid pressure of 1.2 Newton per mm squared. Determine first one, longitudinal stress developed in the pipe, second one, circumferential stress developed in the pipe. Given data, diameter of pipe D is equal to 1.5 meter, therefore convert to mm, 1.5 in 10 to the power 3 mm. The thickness T is equal to 1.5 centimeter, then 15 mm. Internal fluid pressure P is equal to 1.2 Newton per mm squared. To find longitudinal stress and circumferential stress. Solution. As the ratio T by D is equal to 1.5 into 10 to the power minus 2 divided by 1.5. Therefore, equal to 1 divided by 100, which is less than 1 divided by 20. Hence, this is a case of this cylinder. Here, unit of pressure P is Newton per mm squared. Hence, the unit of sigma 1 and sigma 2 will also be in Newton per mm squared. The longitudinal stress sigma 2 is given by equation sigma 2 is equal to P into D divided by 40 is equal to 1.2 into 1.5 into 10 to the power 3 divided by 4 into T value 15. Then we got the sigma 2 value 30 Newton per mm squared. The circumferential stress sigma 1 is given by equation sigma 1 is equal to PD divided by T2T. Then we substitute the value for PD. P is equal to 1.2, D is equal to 1.5 into 10 to the power 3 divided by 2 into T. T value is equal to 15. We got the value for the circumferential stress sigma 1 equal to 60 Newton per mm square. Result, longitudinal stress sigma 2 is equal to 30 Newton per mm squared. Circumferential stress sigma 1 is equal to 60 Newton per mm squared. Then next, example number 2. A cylinder of internal diameter 2.5 meter and of thickness 5 centimeter contain a gas. If the tensile stress in the material is not to exceed 80 Newton per mm squared, determine the internal pressure of the gas. Given data, internal diameter of the cylinder D is equal to 2.5 meter, thickness of the cylinder T is equal to 5 centimeter, maximum permissible stress is equal to 80 Newton per mm square. To find internal pressure of a gas P, maximum permissible stress is available in the circumferential stress sigma 1. Circumferential stress sigma 1 is equal to PD divided by 2T. Therefore, sigma 1 is equal to 80. We don't know the P value. Then you substitute the D value 2.5 into 10 to the power 3. Then 2 into T value 50. Then we got the P is equal to 3.2 Newton per mm squared. Internal pressure of the gas is P is equal to 3.2 Newton per mm squared. Thank you.